Yes, you can go ahead. Hello.
Hello.
Yeah, hello.
Yeah, Radhika, over to you.
Yeah. Hello. Good evening, everyone. Welcome to the MATLAB session, day 4. Today we have Venuda with us. He is in second year of his MS in Control and Automation. He has completed a course in numerical computation from NPTEL and has some prior experience in MATLAB. So now I would like to call Venuda to continue the session.
Yeah, thank you, Radhika, for introduction. So, so I am starting my session on MATLAB. So I will cover some topics of numerical computations, like how to solve linear equations and non-linear equations. So, so I can share my screen now.
Yes.
Okay. So we already know about linear equations. Okay. So like solving x1 plus x2 equals to 2 and x1 plus 2x2 is equal to 3, we know how to solve this linear equation. So basically what we will cover in this is like how do we get the rank of the matrix in MATLAB, and how do we solve these types of linear equations. So in this I have taken two variables. We can take three variables, four variables, five variables, etc. Okay. So yeah. So uh, am I audible? Please, I want to hear some.
Yes.
Yes. Okay. So let me share some basics of linear algebra. Let me do some basic topics. Okay. Yeah. Yeah. So we know about how do we get a unique solution, zero solution, and infinite solution of system of linear equations. Okay. So here in MATLAB, as you can see the codes. So here I have we have equations like x1 plus 2x2 is equal to 1, x1 minus 2x2 equals to 4. Okay. So so how do we solve this equation in MATLAB? Okay. So we can have a matrix for these as 1 2 semicolon 1 comma minus 1, and b matrix as 1 comma 4. This we already know. Okay. From the coefficients of the linear equations in x1 and x2 variable, and the other side is the constants. Okay. So let me just show you the code how it works. Okay. So rank A will give the rank of the matrix A, which is 1 comma 2 semicolon 1 comma minus 1, and rank A comma B will give the rank of the augmented matrix. Okay, so we know that if the rank of the matrix is n, so then we will have a unique solution. Okay, so here we can see, let the MATLAB run this code. Okay, so we got the answer. Okay, the rank of the matrix A is 2 and the rank of the augmented matrix A comma B is also 2. So in this case, we will have a unique solution. Okay. Similarly, for when do we get zero solution? When do we get zero solution? When the rank of the matrix A, okay, when the rank of the matrix is not equals to n, okay, then we get the and the rank of the matrix A is not equal to n and also not equal to rank of the augmented matrix. In this case, we get zero solution. Okay, so let me give this example in MATLAB. So the zero solution we have x1 plus 2x2 is equal to 1, 2x1 plus 4x2 equals to 4. Okay, so in this case, hello.
Yes.
So, so for the zero solution, we will have these equations. Okay, so let me see if there is mistake. Okay, okay, I have written this 2 times, so this is must be. Oh, okay, so got it. So here we see the rank of the matrix A is 1 and the rank of the augmented matrix A comma B is 2. Okay, so this is the case of the zero solution. Okay, the rank of the matrix A is not equal to rank of the matrix A augmented by. In this case, we get zero solution. Okay, and also for infinitely many solution, I have taken an example x1 plus 2x2 equals to 1, 2x1 plus 4x2 equals to 2. Okay, so let me give you this example. So in this case, the rank of the matrix A is 1 and the rank of the matrix A comma B, which is augmented matrix, is also 1. So in this case, we have infinitely many solutions. Okay, so how so these are the basics of the linear algebra, like unique solution, zero solution, and the infinitely many solution. Okay. So I want also to cover some topic like condition number, which is the ratio of the which is the ratio of the maximum value of the eigenvalue to the minimum value of the eigenvalues. Okay, let me give you. Okay, so what is condition number? Okay, it is the ratio of lambda max to the lambda min, where lambda is the eigenvalue of the matrix A. Okay. So in MATLAB, we have certain means we can say um, least count. Okay. So these two equations which you see here, x plus 2y equals to 1 and 2x plus 3.999y is equal to 2.001 has the solution x equal to 3 and y equal to minus 1. Okay. And also the same equation with just variance means 2.001 is written as 2. We will have completely different solution x equal to 1 and y equal to 0. So these depend upon the condition number of the matrix. And what is the condition number of the matrix? It is a ratio of the maximum value of the eigenvalue to the minimum value of the eigenvalue of the matrix A. Okay. So how do we find the condition number of a matrix? We can simply go so let me share the MATLAB screen. Okay, so the previous two equation which I showed can be written in the form of A and B here. Okay, so these are the equations A and B matrix. So how do we find the condition number of the matrix A? So clear workspace and the condition control C, control V. Okay, so the MATLAB command is condition A. So the answer is 2.499 into 10 raised to power 04. Okay, this is very high number. Okay, into 10 raised to power plus 4. So this matrix is known as the poorly conditioned matrix. Okay, this should be minimum so that the matrix should be very well compact. Okay. Okay. So this much is clear. Okay, if you have any doubt, you can ask. Okay, means I am just uh, showing. If you have any doubts, you can ask. So this, I think, the up to this is everything is clear. Okay. So let me just move to the first equation in which we got the unique solution. What was the matrix here we had? We had A and B matrix like this. Okay. So what is the matrix we have? A is 1 comma 2 and 1 comma minus 1. And what the B matrix we have is B. So how do we find the solution? This means this has a unique solution. Okay, so how do we find this unique solution? Okay. So how do we find the solution of this A and B matrix? Uh, A and B matrix. So what will be the solution? Okay, the solution will be simply I and B A into B. So 3 comma minus 1. Okay, you got the answer 3 comma minus 1 for the linear equation in two variable. This is how we do. We also use the operator, means left division operator. How do we use that left division operator? A slash, okay, slash B. Same result. We are getting 3 comma minus 1. So this INV A multiplied by B is same as A slash B. Okay, not the right division. Okay, so I want to give some hint about the right division and the left division. Means these are the completely different division. We don't just use right or left. These are different. For this INV A multiplied by B, we get the actual solution. Okay, not A right division B. Okay, so left division. What is okay here? Here I want to show INV inverse of A multiplied by B is same as A slash B. Okay, not A slash B. A slash B is known as right division. When do we do that? The right division means the right division solves the system of linear equation XA multiplied XA is equal to B. Okay, the left division solves the system of linear equation AX equal to B. In matrices, we solve the first one. That means this one. Okay, we solve this one, not this one. X equals to B. So just keep in mind, we have to use the left division. Okay. So this was the case for the unique solution. And what does the MATLAB give for the zero solution? Let's just check. I also don't know, but it will surely not give any solution. Control C, Control V. Okay, what is the A matrix we have? A is this one. What is the B matrix? 1 2. Okay, sorry, we are getting the wrong result. This is we are getting. So what does the MATLAB give for the zero solution? What does the MATLAB give for the zero solution? Let's just see. Control C, Control V. What is the A matrix? A is this one. What is B matrix? B is this one. So what will our answer have? I and V of A multiplied by B. What does the MATLAB give? Let's just see. Wording. Matrix is singular or working precision. Matrix is singular. What does it mean? Matrix is singular means its determinant is equal to 0. So the MATLAB says the matrix is singular. We cannot have any solution, which we also got by using the rank of, which we also know by the rank of the matrix. Okay. Similarly, we can check for infinitely many solution. What is the equations of infinitely many solution? These are the equations. Okay. What is the A matrix do we have? Is this one. What is the B matrix? B. So let's just check what does the MATLAB give. Infinitely, matrix is singular or working place. The same answer means matrix is singular means its determinant is equals to 0. Okay, clear workspace, clear command window. Okay, so I think this is the up to this everything is clear. We know about the basic of how to get the unique solutions, how to get the zero solution, how to get the infinitely many solutions in MATLAB. This is just the basics, means this for two variables. Similarly, we can do for n number of variables. Okay, 3, 4, 5, 6. Similarly, we can do this. Okay, so the I think this up to this everything is clear. Yeah, you can tell me, means I'm just moving too fast. If there is any doubt in the code or you want to see the codes a little bit from your side, you can just say, and I'll just pause for there. You just look at the code and see if you find any difficulty in that code. Okay. So the next thing I want to discuss is the Gauss elimination method. Okay, the Gauss elimination method for solving the linear equations. Okay, so I will explain the every code of the Gauss linear equation. You just also see the code of the Gauss linear equation. We will see together. Just ask if you have any doubt in the code. Okay, you can ask in the chat box also. Okay, so I'm starting Gauss elimination method for solving the linear system of equations. Yeah, I will share the screen. Uh, Before starting Gauss elimination method, I will just brief about how the Gauss elimination method actually works. Okay, so what is the algorithm we have for Gauss elimination method? So in Gauss elimination method, let's just suppose the matrix is n by n. Okay, we use only square matrices for Gauss elimination method. Okay, means now we are considering for Gauss elimination method means square matrices. Okay, so we take every element a I comma I, that is known as the pivot element. A I comma I means what are the elements we will have? A1 comma 1, A2 comma 2, A3 comma 3, A4 comma 4. So ठीक है. So let's see here only 3 by 3 matrix. So how many pivot elements we will have?
Three.
3 3 3 3. We will have 3 pivot elements. So in the Gauss elimination method we do, in the Gauss elimination we do, we just use the one pivot element, make all the elements below it 0. Okay, so let's just suppose I have taken a 1 comma 1 as the pivot element. Okay, so other the other two elements which will be 0 in the next process will be a 2 comma 1 and a 3 comma 1. Okay, the next method we take a 2 comma 2 as the next element and make a 3 comma 2 equal to 0 by using what? By using these equations. Rj is equals to Rj minus alpha ij multiplied by Ri. where alpha ij is equal to a j comma I divided by a I comma I. Okay. J here is the next element of the next row of the pivot element. Suppose we are taking A11 as the pivot element, then the other means J will be 2 and 3 and 4 and 5 if we are taking 5 by 5 matrix. Okay, clear? So I'll share the code. I'll share the code of Gauss elimination method. How we will I will show how we are making this. Okay. So I have taken 3 cross 3 matrix, means three variables in which the A and B matrices are this one. Okay. So यहाँ पे A matrix ये है, this one is the B matrix. What will be the augmented matrix? This one will be the augmented matrix. Okay. Here we will have two pivot element, A1 comma 1, A2 comma 2, and A3 comma 3. But we don't have any other row after A3 comma 3. So we will just use A1 comma 1 and A2 comma 2 as the pivot element to make the columns below it 0. How we will use? Means make we want to make the here 2 and 3 to be 0. Similarly, if we take a2 comma 2 as the pivot element, that means 1 here as as pivot element, the next below it 4 will be 0. Means we have to make like this. Okay, so we know the A matrix, we know the B, and we know the augmented matrix. Okay. So also just how do we do this? So here we can see A11 as the pivot element. Okay. We use A11 as the pivot element. Now the alpha value for this, for the second row, what will be the alpha value, so that we make the next row's element, means A2 comma 1 element to be 0. Okay. So let me just yeah, control C, control V. Okay. So now if we just maybe so okay. So you see, means A11 was the pivot element here, and we have made the element next below it, that next below it 0. Okay. So we have done this step. Similarly, we use A11 as the pivot element and make the row below it, means below 0. That means here 3 to be 0. For this the for this the alpha will be different. What will be the alpha? Alpha will be A3 comma 1 divided by AB 1 comma 1. For every row, means what we used to do previously when we are in class 12th, we used to find the alpha so that the elements below it to be 0. Okay. Likewise, it is also Gauss elimination, but it is more appropriate. Okay. So how do we use the element? How do we make element 3 to be 0? We again find the alpha. We again find the alpha. Means this step. This step. We again find the new value of alpha, so that when we multiply this with R1, we get the element 3 to be 0. Let's just this. And how will they AB? See, now the element 3 becomes 0. Likewise, all the elements of this matrix will be updated. Okay, so what have we done is we have taken a11 as the pivot element and make all the elements of the column below it to be 0 and 0. Okay, so we have taken a1 as the pivot element. Now our job is to make AB 2 comma 2 as the pivot element. Okay, so that the matrix so that the element 1 becomes 0. For that the value of alpha should be different. What will be the value of alpha? The value of alpha would be this one. Okay, the value of alpha will be this one. Okay, we have the new value alpha, that is -1. Here we got the updated value of alpha, and now we want to make the 1 to be 0. How do we do that? By implementing this one. See, yeah, see, we got the element 1 to 0. So what do we see here? What do we see here? It is means upper triangular matrix. Okay, let's just forget about the 4, 1 and -4. This one is known as upper triangular matrix. Okay, we got A, B, A, B. अपने को A, B matrix मिल गया. Okay, so now we want x1, x2 and x3 as the what do we want? We want x1, x2 and x3 as the final values, because the main aim was that. So now it becomes simple. Okay, now it becomes very simple. So how it becomes very simple? So just see here. Okay, it is the what is this equation? Let me just write somewhere what the equation AB means. Okay, what the equation AB means. The equation means as simply x1 plus x2 plus x3 equals to means 4. Okay, and what is the other equation means? Other equation will be free from x1. It will only have x2 and x3 minus x2 plus x3 equals to -1. Okay, what will be the next equation? Next equation will also be divided from x1 and x2. That means only x3. What will be this? Minus 4 into x3 equals to -4 into x3. Okay, so it is very simple. How it is very simple? From the third equation, we can see that the x3 is equals to 1. Okay, how do we get x3? X3 will be the a comma b and a3 comma and divided by a3 comma 3. Control C, control 1. See, we got the answer. Means how it is getting the how it is solving. Let's just see. AB3 comma n will give -4 and AB 3, 3 will give -4. So -4 divided by -4 will give 1. Similarly, we can do for others. We can find x2 and x3. Control C, Control V. Okay, so let's just find C. The answer we got is x1, 2, and 3. Okay, just see the code. Okay, if you have any doubt in the code, please ask. Means any doubt in the code. Okay, so let me just clear the doubts in the chat box. Okay, I haven't been seeing the doubts. So let me just stop screen sharing and okay, there is any doubt. What is the meaning? Okay, what is the meaning of AB 2 comma colon? Okay, Pradeep, AB 2 comma colon means the uh, AB matrix second row all the elements मीन्स सेकंड रो के सारे एलिमेंट्स जो है वो ए बी टू कॉमा कोलन में अपने को मिलेगा ओके ए बी टू कॉमा कोलन ए
Okay, sir. Okay.
हेलो
Okay, sir. Thanks.
ओके हाँ कोड शेयर मिल जाएगा कोड शेयर हो जाएगा पहले क्लास हो जाए फिर पूरे कोर्स देते हैं आप प्रैक्टिस करते रहिए सो अगेन ओके so means Gauss elimination method is over now okay
Hello, sir.
now I am moving hello
Sir, I have one doubt.
हाँ
If we want to take input, like here we are just giving the A matrix in the code, but
okay
we doesn't want that. We want that anyone else put their input.
okay
Then how we will ask for that input, sir, in this code?
ओके गॉट इट उसके लिए अलग कोड लगेगा ना मीन्स इनपुट के लिए अलग कोड लगेगा
Okay, sir.
है ना उसके लिए क्या लेंगे उसमें इनपुट डालते हैं उसके लिए जैसे कि मेरे ख्याल से इनपुट 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 मैट्रिक इनपुट कीवर्ड जो होता है वो यूज होता है ठीक है इनपुट कीवर्ड
Okay.
ओके वो होता है सब हो जाता है इफ यू विल डू everything happens so right now we are discussing Gauss elimination method
Hello,
hello
hello, Vinod.
hello
I have doubt. Suppose we have a matrix, and any one of the diagonal element will be zero. Then code will be valid.
please ask one more
If,
time
if diagonal element will be zero,
okay
then while calculating alpha,
okay
any diagonal element will be zero. Suppose first row, the element in first row and first column, or second row in second column, or third row in third column will be zero.
okay
Then this code, I think this code will.
yeah this code will not work because we will have infinite value divided by 0
So how can correct it then?
yeah thanks for the questions actually I haven't thought that previously so Oh, what do you think? How do we correct that? How do we correct that?
When we are doing analytically the Gauss
Okay.
elimination, then in that case we generally made it diagonal. The matrix we made it diagonally dominated matrix. Means we
Yeah, yeah,
uh,
yeah. Hello.
yeah, I'm listening.
Diagonally dominant matrix. Yeah, true.
Initially we changed the rows, and after that we proceeding while doing analytically. I don't know about how to write code for that.
Okay, okay. Yeah, yeah. सही है, सही है. We have to make it diagonally dominant matrix. Thank you, thank you.
Initially we will change the rows, right?
हाँ, yeah.
So
Accordingly we will make A matrix and B matrix.
okay.
हाँ. We have to first make sure that it must be a diagonally dominant matrix. Okay, let me just recorrect and write here. Okay, thank you for the update. So I think Gauss elimination method, we are okay. We have done okay. So next, I have shown one method for solving linear equations, and one. Now we will move to non-linear equation in single variables. Okay, how do we solve non-linear equations in singular for singular value, single variable? So let me just brief about. Okay. Okay. Here is the equation. Okay, this equation is in single variable 2 minus x plus log x equal to 0. Okay, the graph of this equation is like this, which I have shown here. The solution is point 0.5, the answer is 0.1586 and 3.1462. We have to find x such that f of x equals to 0. Okay, so the method here which I am discussing is known as bisection method. Okay, we also have Newton-Raphson method for solving this type of linear equations, single variable, non-linear single variable equations. So bisection method and Newton-Raphson, these two methods we have. We have many other methods. Okay, so but right now I am discussing these two methods. Okay, let me just discuss some Newton-Raphson method. Okay, in Newton-Raphson method, we initially make guess. Okay, uh, we have to guess initial values. Okay, after that we make iterative method so that xi plus 1 such that xi plus 1 equal to xi minus f of xi divided by f dash xi. This is the Newton-Raphson method. This Newton-Raphson has said. Okay, so for every iteration we update the value of x till some limit. Means there should be a minimal limit. Okay, if there the difference between the xi and xi minus 1 is very small, then we will stop. up to a certain limit. Okay, the equations which I have taken is f of x equals to 2 minus x plus log x. Okay, now f dash x will be minus 1 plus 1 by x, minus 1 plus 1 by x. So this we have to code. Okay, this equation, these three equation. Okay, now how we have to do repetitive tasks, we have to solve this equation xi plus 1 equal to xi minus f of xi divided by f dash xi many times, so that we will use for loop here. Okay, how do we do that? How do we do this? Let me just show you. Okay, Newton-Raphson. Okay, to solve nonlinear equation using Newton-Raphson method. So I have already written the code. Okay, just see the code. I'll explain the code step by step, and you also see if there is anything you are finding difficulty in the code, please ask. I will also explain the code. So okay, I'm explaining. What does Newton-Raphson method does? It takes the initial value. It takes the initial value and does do the repetitive task such that minimum difference between the two does not exceed that limit. So here we have minimum differences 1 e raised to power minus 4. We have taken the maximum iteration value as 30 and the initial value as 0.2. Okay, initial condition, and the equations is 2 minus x plus log x. So here I have used for loop for I equal to 1 to max हिस्टर. मैक्स हिस्टर की वैल्यू कितनी है 30 है. f of x is equal to क्या था अपने पास 2 minus x plus log x. What was the okay यार मैं यहाँ पे लिख initial function differentiated function equation. Okay, what was the updated value of x? X equal to x minus f divided by df. Okay, this was the Newton-Raphson method. So this so every time the loop gets initiated, we update the value of x. Okay, and we have some error limit, means every time the loop does, we have recording the error. Error is what? Error of I equal to absolute value of x minus x old, means the previous iterations value and the new iteration value. If error of I is less than tolerance value, then the loop will break and we will have the final value of x. Okay. Okay. So how many iterations we have here? We have 30 iterations here. Okay. So let's just run this code and see how does it gives the value. So let's see. So we have got the value x here as 0.1586. What is the value of x here? 0.1586, which is same as here 0.1586. Okay, we have taken the initial value as what we have taken here. Initial value x0 is 0.2. Okay, we have not got the other value. We have not got the other value, which is 3.1462. How means the closer we take the initial value, the same way the solution gives according to that. Okay, we have taken 0.2 here, so it gives the value 0.02 here, so it have given the next possible solution, means the solution which is clear, which is closest to this, that is 0.1586. Now if we take the initial value as suppose 2, then we will then we will have the other solution, that is 3.1462. Let's just take the initial value as okay. Let's just take the initial value as 2. Control C. See what is the value of x? 3.1462. We got the other value of x. Okay, got it. Okay, so चलो मीन्स कोर्स तो पहले से रन है, उसको रन कराने से कोई मतलब नहीं है, तो मैं लेट्स जस्ट हैव some update in the code. Okay, how do we update the code? Means how do we code? Okay, suppose we want to have the value of x, means we want every value of x at every iterations. Okay, here we are just updating, we are not storing the value of x. Suppose we want to store, or we want also to store the value of x and also want to display it. Okay, in this code we are just updating the value of x, not storing the value of x. Okay, so how we will store the value of x? Okay, for storing the value of x we have to make some uh, variable. Okay, so how many values of x will we have? We will have 30 different values of x, because we are iterating 30 times, so we will have 30 different values of x, and we want all the values of that x. So let me just make another way, t equal to zeros, zeros, 30 rows, comma 1. What it will have? It will have all the, it will have the t will have 30 rows of 0. Now we will store every value of x in that t. Okay, how we will do that? Okay, t of I equals to x. Simple. Means every time we are getting the value of x, we are storing the value of x in t of I. Then we will get every value of x. Okay. So let me just run code control V. Okay, so the value of x here will, all the values of x will be okay. Okay, got it. We are only getting the 4 value of x, the other values become 0. It means that we are getting our desired answer up to 4th iterations only. See, I is equals to 4 here, means at till 4th iterations we got all the values of x. After that, the after that this statement got executed if error of I is less than tolerance of x. 4th iteration means the loop will break, and the final answer will be x. So after 4th iterations this statement got executed. Why it executed? Because error of I is less than tolerance of x, which we have already assigned. Tol of x is 1 e raised to power minus 4. Okay, if we had different okay, so let me get the other value of x. Other value of x, we have to take other initial condition 0.02. Okay, control C, control V. So what were the values of x we have? T, C. Up to how many iterations the loop executed? 1, 2, 3, 4, 5, 6. Up to 6 iteration. Up to sixth value of I, uh, we have executed this code. Okay. So done up Newton-Raphson. This is Newton-Raphson. So just please see this code and you can ask. Okay. So Newton-Raphson method is also done here. So in this lecture, I have discussed one method, that is Gauss elimination method for solving linear system of equation. And in other lecture, I have shown non-linear equation by using Newton-Raphson method. So what if we don't know the code and also want to solve the linear equations? Okay, so we have MATLAB. Means MATLAB is very famous software. It has some inbuilt functions. Okay, so why don't we just use that inbuilt functions? Okay, so we have one MATLAB command known as F0, which we use to solve the nonlinear equations. Using MATLAB command F0, means by using the MATLAB command F0 we can directly get the value of x without writing any code. It solves nonlinear equation in single variable. So what are the details of this MATLAB function or MATLAB command? We have to write strictly the according to the equation that is given here. Okay, so there is a small mistake here. The x will be covered by a small bracket, which I will show in the code. Okay, so MATLAB code. Okay, so you have to write strictly according to this. Means x solve equals to f0 at the rate x fun to x. What is fun to x? Fun to x is the name of the function in which we are passing the variable x. X here is the unknown, and means what the fun to x is returning. What the fun to x is returning fl. The value of fl is 2 minus x plus log x. Okay, so it is returning this equation, which we have solved by using Newton-Raphson. Okay, and what here we have to give? We have to give initial guesses. Okay, what initial guesses we have given is 1 semicolon 4. Okay, we have to give initial guesses such that the it is most means it should the initial guesses should be such that it is close to the solution. What was the answer with that we got for solving the value of x is 0.1586 and 3.14. So here the value of x is 1 and 4, means lower limit is 1 and upper limit is 4. So in between these, whatever the solutions nonlinear equation will have, it will give its solution. Okay, clear workspace. So let's just run this code. Control C, Control V. It is solving. Means please take care of the signs. Means it should be uh, very according to the syntax. Okay, means at the rate should be at the rate, and small bracket should be x. Then after space, okay, we have to give space. Then write the name of the function in which you have stored the equation. Okay, then comma, then initial guesses, lower limit and upper limit. So here we have x solve. Okay, what answer we have got here is x solve equal to 3.1462. Okay, 3.1462. What was the other what was the other answer for the equation was 0.1426. For that we have to change the initial value. Why do we have changed? Because it does not lie between the upper limit and the lower limit. Okay, for that we have to do 0.02, and let's just write here is 1. Okay, control C, control V. See, we have got the answer as 0.1586. Okay, so the two guesses for was 1 semicolon 4 and the other guess was 0.02 and 1. In both this we have got both the solution, that is 3.1462 and 0.1586. Okay, so I think I have covered in I have taken one hour already. So if there anything you want to ask, you can ask. I will share the code.
Anyone from the participants? Do anyone have any questions?
Hello, sir.
Hello.
Sir, just I want to change the limit, like you have put 1 and 4 initial guesses.
Okay.
Sir, put 0 and 6. I want to
Okay.
see that which solution it will give, either 0
Okay.
point something or 3 point.
Yeah. You cannot put 0 because we have in the denominator log. We have to calculate log now.
Yes, sir. Means we can put 0 point something, 0.5, or means
Okay.
left side of the smaller solution.
And what will be the upper limit?
5, sir.
5. Okay. Let's just do this. I also don't know. Let's just see what MATLAB gives the answer. Okay. The MATLAB says the function values at the interval endpoints must differ in sign. You got it?
Sir, can you repeat?
the function values at the interval endpoint must differ in sign.
Okay, sir.
Uh, you got it? समझ आए? Means you have to put such that the it must cross. Means the solution.
Like in bisection method,
हाँ
we
हाँ.
yes, sir. Okay, sir. Got it.
Okay.
Yes.
It also solved by the same method. MATLAB also solved by the same method. It doesn't do it differently. So you have to give the interval such that the solution must lie between that intervals.
Okay, sir. Okay.
Okay.
Thank you, sir.
Okay. Okay. Thank you. Thank you. Anything? Anyone asked to some question? Okay. I'm sharing file in the chat box. Is it okay? So up to this, I want to cover in this MATLAB sessions. If you all want to do more, you can follow MATLAB. Means in YouTube there are many different good courses. I have also learned from that. I also have learned from that. Okay, so if you want to means dig more to the topic, you can follow Niket Kesare search NPTEL lectures. He has covered many means in details and in very good good way. More means many times good way more than me. Okay.
So, Venudar, do we have anything more or can we bind up?
Yeah, we can wind up. Then, but the student are asking the code to be shared. So I think we can share it. Okay, means in 5 minutes. Okay, Radhika,
Yeah,
I can. Yeah,
Venudar,
can I?
we can share it on Slack, I think.
Yeah. That will be good. I'll share with you, and you can share with them.
Sure, sure.
Sure. So
Shall we
thank
end
you,
the session?
everyone. Yeah. That's just me. And me with some lessons.
You can share the file at both places, Slack as well as WhatsApp.
Yeah. So thank you everyone for listening me patiently. Okay, thank you everyone, and
Thank you.
hope you will enjoy the MATLAB
Thank you,
session
sir.
accordingly.
Yes, sir. Yes, sir.
Okay, have a good day.
Same to you, sir.
Thank you, sir.